So just like with fractions, you want to have things in their simplest form. Okay? To get it into simplest form, we're going to have to factor if possible. So if things can be factored, you will want to factor them completely. Once things are completely factored, then you're going to look at your fractions and see if there are factors that are identical, they can be simplified. If there are factors, if there are just numbers in front, for example, in this first one, negative 25 over 35, can that be simplified? If it was just numbers, yes. You could write that as negative, divide them both by 5, 5 over 7. So that's a start for simplifying it. You could simplify just the numbers. If you have variables by themselves, what's going to happen if you have a cubed over a? You have a times a on the top and 1a on the bottom. It's going to be left with a squared on the top. What about the b's? You've got b times b on the top, and you've got b times b times b times b times b on the bottom. We're going to be left with b cubed on the bottom. And we still have a single c on top, and that would stay there. So if you just have a monomial divided by a monomial, as we have in this case, you just do each one separately, simplify the numbers, simplify the variables, and you're fine. But in b, okay, for b, I'm going to start a new page here for each of these. What we're going to do as our main strategy is we're going to factor. If we can factor things, that'll make things easier. Can you factor the top here? Yes. There's a common factor. What could you pull out? You could pull out, well, is 3 the biggest thing you could pull out? Is a 6. And an x. What would you be left with? What would be left here? You'd be left with an x plus 2. And we have 3x on the bottom. So now this first part right here, can you simplify 6x over 3x? Yes. The x's will go away. 6 divided by 3 is just 2, and you still have x plus 2. And you can leave your answer in factored form. And it's fun when you cancel things out to sort of make Star Wars sounds. Just makes it more enjoyable. December 18th. Now, a key thing about simplifying, and you will be tempted by this. You will be very tempted. You will be tempted to do this. Because they're the same. So why can't we cancel them out? Okay? That is not allowed. It's the same reason, right? What's this equal to? Can I cancel out these 3's and say it's equal to 3? No. The reason is because we're adding. Okay? But if you changed adding to multiplying, right? This is really 2 times 3. As soon as you have multiplying, then canceling is allowed. Okay, 3 plus 3 is 6. 6 divided by 3 is 2. Okay, you can't cancel out when it's adding. So right now, I'm adding and subtracting. I'm not allowed to cancel out. But if I am multiplying, then mathematically it makes sense to simplify. So we need to change things from adding and subtracting to multiplying. And the way that we do that is by factoring. How do I factor the top? X plus 7 and x minus 7. How do I factor the bottom? X and x. It's got to be 7 and 2 to get 14. The 7 has to be negative. The 2 has to be positive. Then you look, do we have anything that's identical? Because we can only cancel out factors if they're identical. So anytime that it's adding and subtracting right now, whatever's added and subtracted gets grouped together. So that whole thing would get grouped together as one factor, and this whole thing gets grouped together as one factor. And the only way factors can cancel out or simplify is if they're identical. So in this first part, nothing's identical, nothing I can cancel out, because this is all grouped together on the bottom, and that's all grouped together on the top. But as soon as I factor it, now I have two groups on top and two groups on the bottom. These ones are identical, and so I can cancel those out, and we get our final answer as x plus 7 over x plus 2. And that is the simplest form. You can't simplify those x's because they get grouped together, because it's adding on the bottom, as x plus 2. You could write this final answer like this. That would be fine. But it wouldn't be wrong if you kept it in brackets, because you had it in brackets after you factored. And the last one here. So again, this is subtracting, so currently that's grouped together. All three of these are subtracted together, so those are all grouped together. They're not the same, so you can't simplify anything here. If we factor, the top, it would have to be 2x and x. It's going to have to be 3 and 1. Is it going to be 3 and 1 or 1 and 3? Okay, I heard some people say 3 and 1, 1 and 3. We're going to need to do 1 and 3, because 2x times 3 will be, if I make that negative, will be negative 6, plus 1 makes negative 5. On the bottom, can you see the bottom is a difference of squares? It's going to be 3 minus x and 3 plus x. Are any of them identical? Which ones? There's x minus 3, but this is 3 minus x. Is that the same? Like if I put in 1 for x, what's 1 minus 3? Negative 2. And if I put 1 in 3 minus... So far, nothing's the same. This is where, though, put a little special note off to the side. Okay? Look what happens with 3 minus x. When you have nothing in common, would you agree that 3 minus x is the same as having a 1 out in front and saying 1 times 3 minus x? Okay? I could, though, also take out a negative 1. What would happen if I took out a negative 1 out of here? What would happen to the 3? It would become negative 3. What would happen to the negative x? It would become positive x, or negative 1 x minus 3. So whenever you have a binomial that's just flipped with the minus sign in between them, like we have here, x minus 3 and 3 minus x, what you can do, rewrite it here, you can factor out a negative 1 and now we have two factors that are identical. And we're left with 2x plus 1 over negative 1 times 3 plus x. So numbers you can do for this one. And these will be the most important ones for you to practice, because you want to practice getting things into simplest form.